This is HRW98P045. We've got a rope is used to pull a block at constant speed across a horizontal floor. The force on the block they give us, and it's at an angle. So what is the work done by the rope's force? This is the easiest one on here. The work is the force of the rope times the distance it's pulled times the cosine of the angle between them. They give us all of that, okay? So you just plug the numbers in. Cosine of 15, and when you do that you get 32.4 joules. Okay, then it asks, what is the increase in the thermal energy? Well, this box, we just did work on it, so technically speaking the box's energy should have increased by that much, 32.4, but it didn't because it was pulled at a constant speed, so the kinetic energy didn't change. It's on a horizontal floor, so the potential energy didn't change. The energy didn't change at all. So although we added 32.4 joules, it didn't get added to the box, so it must have been added to something else. The only thing that's available is the thermal energy. So that must be it. It's got to be the same thing. Okay. Lastly, what is the coefficient of kinetic friction between the block and the floor? So thermal energy is increased by friction. Basically, whenever friction does work on something, it does negative work. It always does negative work, and on the object, and so it takes that energy away, and it kind of like, I don't know, it's the thief, and then it gives it away to the thermal energy. I don't know, like Robin Hood or something. That sounds stupid. Sorry. I've already done this one 3 times because my computer keeps being annoying, and like the first time it froze in the middle, and the second time I accidentally closed everything before saving it. So I'm all, yeah, anyways. So I know that the work done by friction is the force of friction times the distance that it was pulled. There's no cosine on this one because the friction is parallel to the floor, and the box moved parallel to the floor. So I don't have to worry about any cosines here. Well, friction is mu times the normal force. So basically mu is going to be divide both sides by normal force in d. It's going to be the work done by friction divided by the normal force times d. I've got everything here except for the normal force, so I need to go find that. Let's go find that. Well, I know that since this was pulled at a constant velocity, the net force is 0, and that includes the net force in the y direction. The net force in the y direction, I've got the normal force pointing up, I've got the y component of the rope pull pointing up, and then I've got gravity pointing down. So that's all I can equal 0. If I solve for n, just move all the other stuff to the other side, I get this, which Fy is just F sine theta. All of which I know. So I plug in everything that I know. So mass times gravity minus force times the sine of 15, and I get 33.11 newtons. I plug that in over here to go back. Oh, here we go. No, come on. Plug that in. I've got the work already from the last problem. Now I have the normal force, and I had D was given to me. And when I do all that, I get 2.118 something, so that rounds to 2.12.